here, though. How you doing, Rats? I'm sure you're going to watch this, so. Recording it just for you. So. Yeah. Yeah. So, when we take the derivative of this, the derivative of natural log of 3x is 1 over 3x. That is your derivative. But, this is a chain rule, so we took the derivative of the outside, now we have to take the derivative of the inside part, and the derivative of 3x is 3. And that's like 3x over 1, so that gives you 3 over 3x. Those 3's can cancel. And we actually just end up getting 1 over x, just like we would if we had natural log of just x.
Does that always happen with like ln of something?
If it's something really simple, just like a 5x or a 4x, then yes. Okay, so example 2, we're taking the derivative of x times natural log of x. What do we have to use here? Product rule, because we have two things that are multiplied together. So we're going to have x times the derivative of natural log of x, which is 1 over x, plus natural log of x times the derivative of x, which is just 1. Okay? So, this x is like it's over 1, so this is x over x, those x's cancel, we just get 1 here. So 1 plus natural log of x is our derivative here. Okay, questions? Alright, here are our next two. Okay, so for this one, we have a chain rule. The natural log is our outside, the x to the third is our inside. So when we take the derivative of natural log, it's just 1 over whatever is in the parentheses. So 1 over x to the third. But then we have to multiply it by the derivative of the inside, which is 3x squared. So that's like 3x squared over 1. So we'll get 3x squared over x to the third. But what can happen with those x's? They can cancel, so I just end up with 3 over x. Okay? Alright, questions there? Alright, 4 is also a chain rule, but the outside this time is the 5. Our inside is the natural log of x. So when we take the derivative of this, f prime of x will equal, we'll have 5 natural log of x to the 4th power. And then we must multiply it by the derivative of natural log of x, which is 1 over x. So if we multiply this across, we'll have 5 natural log of x to the 4th over x. And there's not really anything you can do with that, so you'll just leave it. Okay. Questions? Alright, now, so these are for natural logs, but sometimes we don't have natural logs. Sometimes we have other bases. And actually, it's very rare that you see other bases on the exam. In fact, I'm not sure you will see them, but I'm going to throw them out here because they're not that much more difficult, and I'm afraid they'll show up, so you'll at least have seen them. Alright, so like we were talking about earlier, that change of base formula that we use, that's what we used in our calculators if we needed to find log base 5 of 9, right? In our calculator, we could type that in as, in pre-cal, we probably did log 9 over log 5 because the TI-84 has a log button, but the TI-89 does not have a log button, so I would use natural log of 9 over natural log of 5. It will give you the same result. And certainly for these problems, we want to use natural logs because we know about the derivatives for natural logs. We do not know about the derivatives for logs, so we're going to switch this to make them natural logs. So, here is our first example. We've got, for example 5, if f of x equals log base 5 of x, then we're supposed to find f prime of x. So what we're going to do for this is we do not know how to take the derivative of a log base 5. But what we can do is I can change this to natural log of x over natural log of 5. Okay? And then this is really helpful because natural log of 5 is a number. I could type it into my calculator, it would give me a number, right? So natural log of 5 is actually like a scalar multiple. What you really have here is you have 1 over natural log of 5 times the natural log of x. And this is a scalar multiple here. It's just a number. And if we just have a number out front, like a 2 or a 5 or a 7 or a 1 over natural log of 5, then we don't have to use it when we're taking the derivative. We just leave it out front, right? So what we're going to do when we take this derivative, we'll say f prime of x equals, that scalar multiple just stays out front, 1 over natural log of 5. Times, now we take the derivative of natural log of x. And what is natural log of x? The derivative of natural log of x? 1 over x. So our derivative we get is 1 over x times the natural log of 5. So if you have to find the derivative of something that has a base other than natural log, then just use your change of base formula, and then basically you're just going to pull 1 over whatever number that is out front and leave it there, right? So let's do one that's more difficult. So we've got f of x equals log base 3 of the square root of x squared minus 2. So the first thing you want to do here is you cannot take that derivative while this is a log base 3. So you're going to have f, we're still f of x, not f prime of x, because we have not taken the derivative yet. We're going to say natural log of the square root of x squared minus 2 over natural log of 3. Now there is a shortcut I could use here that is going to make this a little bit easier to take the derivative of. I know that 1 over natural log of 3 just kind of needs to be pulled out to the front. And that leaves me natural log of the square root of x squared minus 2. That's the part I'm actually taking the derivative of. But I don't like the looks of that because I've got that square root on the inside of the natural log. Which means, as it is right now, I've got a chain rule with like a double chain rule on the inside. Because I would have the square root to deal with plus the x squared here to deal with, and just don't really like that. Is there any way I could get rid of that square root? Okay, I could pull out a 1/2 because this is the same as 1 over natural log of 3 times natural log of x squared minus 2 to the 1/2. And in those properties of exponents that we were learning or reminding ourselves of yesterday, I can pull that out front as a coefficient. So that will make it easier to take the derivative here. So that means it is going to give us a little bit of trouble here because I've got 1/2 divided by natural log of 3. And I don't like having complex fractions. So let's make that 1/2 over natural log of 3 over 1. Dividing fractions is easy as pie. And I get 1 over 2 natural log of 3. So I've got 1 over 2 times the natural log of 3 times the natural log of x squared minus 2. Now I have not taken the derivative yet. This is still just the function. I guess right here you can kind of just think of when you pull that 1/2 out front, if you put it like this, do it like that, that'd probably be easier to think about there. You just multiply those two together and get 1 over 2 natural log of 3. So, now we have to take the derivative. It doesn't look like it, but all of this right here is a scalar multiple. It means just a number. That means we don't do anything with it. We just leave it. So f prime of x equals 1 over 2 natural log of 3. We don't touch that stuff. But we do have to take the derivative of natural log of x squared minus 2. So that would be 1 over x squared minus 2 times the derivative of x squared minus 2, which is 2x. Okay, is everybody with me here? Alright, so now we just need to simplify a little bit. There's not a whole lot that we can do, but this will be 2x over 2 natural log of 3 times x squared minus 2. And we could cancel those 2's. So we would get 1 over natural log of 3 times x squared minus 2. Oh, sorry. Thank you. Put that x back there in the top. Just x over natural log of 3 times x squared minus 2. Okay, questions? Alright, let's look at this one. This will be our last example here. So, I would do a little bit of work on this one before I begin because we cannot take the derivative of log base 2 of x. So what we'll have here, as I work on this, I'm going to keep that derivative notation because I have not taken the derivative yet. So I'll have 8 times, this is natural log of x over natural log of 2 over x. So, here I would multiply these, so that would be, keep your derivative notation here, that'd be 8 natural log of x over natural log of 2 all over x. And then I'm going to make that x over 1. This is a little bit of a shortcut. I don't know if I've told you guys. Whenever we are dealing with complex fractions here, I always say it's easy as pie, flip the second, multiply here, which works well and you can do. Another thing that Miss White used to use a lot is if you flip the second and multiply, the outers, the top and bottom, are going to be on the top. So you'll have 1 times 8 natural log of x. And the inners, x times natural log of 2, are going to be on the bottom. So she would always say outers over inners, so that you don't actually have to write that down when you flip and multiply. So if you like that, use it. Might save you a little time. Now, now we have everything in terms of natural logs and we don't have a complex fraction anymore. There's one other thing we can do to make our lives easier right here. 8 is a scalar multiple. It's just a number. Natural log of 2 is also just a scalar multiple. So what we can do is we can pull those out. Those are just the numbers that we don't have to take the derivative of. So we can look at it like this. 8 over natural log of 2. Those are scalar multiples that we're not going to mess with, times the derivative of natural log of x over x. If it does not have a variable with it. So like something like natural log of 2, natural log of 5, natural log of 7, those are scalar multiples. They don't look like they are, so it's hard to see that you pull those out. But if it does not have a variable, if you're taking natural log of a number, you could type that into your calculator. If it was calculator active, it would give you a decimal. It's just a number. It's just a little hard to see it because it looks like it's some sort of variable with that natural log there. So if you look back at the other ones that we did, see here, this was natural log of 5. It did not have a variable, so we could just pull it out front and not mess with it. Here, we had the natural log of 3. No variable there, so we could just pull that out and mess with it, and not mess with it. Okay? Alright, so we still haven't even taken the derivative here, but once we get it to this point, it'll be much easier to take the derivative. So this 8 over the natural log of 2 is just going to stay out front. We're not going to mess with it. And then what do we need to use to take the derivative of natural log of x over x? Quotient rule. So we'll have x times the derivative of natural log of x, which is 1 over x, minus natural log of x times the derivative of x, which is 1, all over the denominator squared, x squared. So x times 1 over x is just 1. So we get 1 minus natural log of x over x squared. And you're pretty much going to leave your answer like this. They might write it together like 8 times 1 minus natural log of x over natural log of 2 times x squared. They may put it together something like that, but there's not really much to do with that. All right, questions. All right, so we finished a little bit early today. Let me give you your assignments. This comes from that packet that you have there. So from the packet, we're going to do page 319. And you're going to do 41 through 44, 49, and 50. And then on page 354, you are going to do 37, 38, 41, and 45.